literally. See it. Now this one's just going to have one of the big mass. It's going to have so many, you can't even get those separated. Right? Now, each one of these is a representation of one bacteria. We call it, thanks to Robert Koch, a colony. Okay? So that one bacteria, we would call a CFU. Colony forming unit. Okay, colony forming unit. When we get enough,
as a single one or as a whole?
as a single one. So that bacteria originally, before it grew that colony, had the potential of creating a bunch of bacteria. So we call it a colony forming unit. Okay? This is a colony. It's a group of bacteria. They're going to all look the same, so therefore they're going to have the same little dwelling. They're going to look the same. Now, if I have a yellow dot and a white dot and a pink dot, do you think those might be different bacteria? Yeah. Okay, so this might be one type of bacteria here, this might be one type here, and this might be another type here. Does that make sense? Okay, now I can take this one little clump, this one kind of bacteria, scrape it off there, and now I can get me a new potato. And I can take this one and I can shrink it on here. Now, should I have different colors here? Very good. No, I shouldn't. I should have all the same color, all the same shape, all the same size of colonies. Does that make sense to everybody? Now, what I've done is I've isolated this bacteria here and put it on this. We didn't have anything to do that with, so he used potatoes. He was very inventive about that. He used potatoes. Potatoes, like I said, it's not very good because it's really not a good nutrition source. It's just starch primarily. So you may not be able to grow all types of bacteria on it. We're going to learn that as we go through the semester. The different types of bacteria have different nutritional needs. All right? So, that not being the most effective, he tried some other stuff. He tried gelatin, like Jell-O.
Don't onions attract bacteria maybe?
Yeah, kind of, but I mean, they're not going to grow very well either because onions really don't have a lot of nutritional, they have some nutritional value. Let me back up on that before I say that. But they don't have a lot of energy source. Does that make sense? Low calorie content, and they're not going to have a lot of the carbs and the lipids and so forth to look at. Okay. So therefore, you're just not going to grow a whole lot of different stuff on it. So he was using gelatin. Anybody ever taken a spoon? And I'm going to be really gross here, okay? And some of y'all have heard this little story before. Taking a spoon and you have dipped it in your gelatin and taken a bite out of it. If you ever put the spoon back into it, what happens to gelatin?
Starts melting.
Turns to liquid. Those are enzymes breaking it down. So what do you think is going to happen when you put the microbe on it? It's going to break it down, turn to liquid. Okay. So that's a real frustrating thing. So one of his co-workers, co-scientists, colleagues, whatever you want to call them, was really frustrated about this. And he was talking to his wife one day. And his wife said, well, you know what? I think what you need to try is what I put in my jams and my jellies. Anybody do any, I know y'all, nobody raised their hand when they said candy. Jams and jellies even? That's like easy stuff. Okay? Nobody does jams. You at least understand what I'm talking about, right? It's solid. Okay? It's solid because there's a special stuff that you put in it to make it that way. Alright? And it sets up, it's going to be liquid, and then it sets up solid in a gel-like form. Okay? It's called agar. That's what it's called. Okay? It's actually called pectin, if you really want to be technical, if you're looking at it in the canning section. But it's called agar, okay? Same thing. So a housewife made this suggestion. Her name is Franny Hesse, okay? A lot of times we overlook the simple people that make major contributions in the world. And thanks to her, he added broth to that, okay, which gave us our nutritional media, okay? Well, now we can make that sterile. We can solidify it, put it in a little plate, in a dish, and create a medium. That's what we do today. We still use it today. Exact same thing. Thanks to Robert Koch and Franny Hesse, now we can be able to identify and isolate microorganisms. Okay, so that's how important he was to disease causation and being able to isolate one bacteria. Now, who else was trying to do that? Pasteur. Don't you know he wasn't very happy about that? Like I said, one person's going to do something with a thing, the other person's going to be able to finish it, and they go back and forth the whole time. Okay? Very significant people. Alright, so that kind of gives us an understanding of what's going on and how he's going to go about some of these processes of finding one pathogen, okay? So he's studying anthrax. Along the way of studying anthrax, he needs to figure out how one disease-causing agent, one pathogen, causes one disease. And that's how he goes about doing that with the agar, right? He goes through and creates a step-by-step process to verify X pathogen causes X disease. Okay, so for example, the disease is anthrax. The disease-causing agent, I'm sorry for the crazy name, is Bacillus anthracis. Those of you that like Monty Python, there you go. Bacillus anthracis. Hopefully you can read that.
Was this already named or did they come up with a name?
They came up with a name. He didn't coin the name, no. Without knowing this, potato slice method, and agar, he could have done it. Okay? Alright. So, he created steps to verify and validate that one disease-causing agent causes one specific disease. Those steps are called Koch's postulates. Okay, Koch's postulates. Right here. That's going to be page 14. Let's look at those four. First one. The suspected causative agent, that's the pathogen, must be found in every case of the disease and be absent from healthy host. Host meaning who would have the disease, right? Okay. So, suspected causative agent must be found in every case of the disease and be absent from healthy for example, if you had the flu, you show signs and symptoms of the flu. If someone drew blood on you, it'd show you had the flu. You understand that now? Okay? Person beside you doesn't have the flu, draw blood on them, they don't show signs of it. Okay? They shouldn't show signs and symptoms either. Okay? Number 2. The agent must be isolated and grown outside of the host. So in other words, if you have it, I should be able to take it from you, from your tissue of some sort, so like blood, it's a tissue, right? Or from your skin or whatever it may be on. Okay, I can take that, remove the pathogen, and grow it in a lab. So the agent must be isolated and grown outside the host. Number 3. Now we get into scientific research and studies. Now we get into some clinical studies. When the agent is introduced to a healthy, susceptible host, the host must get the disease. Okay? So now you don't have the flu, and I give you the flu, basically, right? I grew it. Now I'm going to take what I grew and give it to you. So I want to make sure what I grew is the right thing. Okay? So now I'm going to grow it and then I'm going to give it to you. Number 4. The same agent must be found in the diseased experimental host. So now I should be able to, okay, let me back up here. I got my sick person. I remove the disease from the sick person, and I grow it in the lab. I take what I grew in the lab, I give it to a healthy person, then I should be able to take that person that I just gave the disease to, now they're sick, right? Get the disease from them again, and grow it in the lab all over again. Does that make sense?
Did people volunteer or did you just do it unknowingly?
Here's the interesting thing about this era. Do we have any sort of litigation over clinical studies? No. Y'all want me to go ahead and say a minute about just this little thing about Jenner? Okay.
What?
Edward Jenner over here?
I thought you said dinner.
Oh, dinner, yes. Dinner's great. Jenner. Sorry. Edward Jenner. Well, he's the guy that is the first person to discover a virus legitimately in Europe. Okay, we always argue who did what first. China always does everything 300 years before Europe, but we won't get into that, right? Edward Jenner, first person to study a virus. He studied and discovered, vaccine. Let me back up, not virus, vaccine. I apologize. Wipe that virus thing off there. Vaccine. He's the first person to discover a vaccine. Okay? Guess what he did? We're talking about experimental studies. No, he didn't. It's even worse, his kid. He did. He gave it to his child. I'm going to give smallpox to, actually it was cowpox, okay, to my child. Oh, he looks like he's fine. Then what does he do? It's something even worse. Well, he looks like he's fine. What are we going to prove? He's not going to catch it, right? We're not going to give him more. We're going to stick him in amongst all the smallpox people. He didn't catch it, so we're good.
You just couldn't use the cell.
Yeah, couldn't use myself, right? Although there was a lot of that conducted and done in that era. Do it to yourself to check it. Yeah. No. But usually people that were adults had already been in contact. Nowadays, what would happen? CPS, right? You're going to jail.